Hello students, welcome back. In today's class, we'll learn about what are the standardization conflicts and software conflicts. Now, software conflicts come which software is best. As I have told you, the standardization depends on the country to country. But in terms of software conflicts, here comes which software is best and how many types of softwares are there. For mechanical and mechanical related branch, there are two types of softwares. One is design, another one is analysis. So the software, in terms of naming, you could say that AutoCAD, SolidWorks, Solid Edge, CATIA, Onshape, Ansys, Console, S.V.I.S.T, StatPro, etc. etc. Now you have to understand, among them, few are being used or you may say are totally dedicated to for designing or drafting. The drafting is only done nowadays. Basically, drafting can be done in all the softwares, but the thing is that the drafting is the pure drafting can be done in AutoCAD. So the design softwares are AutoCAD, Solid Edge, SolidWorks, CATIA, Onshape. So these softwares are totally dedicated for designing and drafting. Now, after designing, it have to be analyzed whether it is safe for our usability or not. For that, we need to analyze the software by using some softwares. The name of the software is Ansys, Console, S.V.I.S.T, StatPro, etc. So what does that mean? That means that the software can be two types. One is we have to design and we have to keep in our head, and then we have to analyze it using Ansys, Console or S.V.I.S.T. Now this comes the overview, but there's another problem with the software. Nowadays the software installation is a very massive thing. Because why, you may ask me why this is a very massive thing? Because while you are going for software installation, you need space or data allotment area in your hard drive. So for that you may not have that amount of hard drive space, so you have to clear up. That can also be done. So there have been three types of installation according to which software has been manufactured. One is your local drive installation, another is the server drive installation, and third is the cloud drive installation or IoT based. So what is local drive installation? Local drive installation is the installed in your computer hard disk, in your personal computer hard disk. Now let us take a computer of an office. If a design office is having 100 of computers, every computer's software like SolidWorks is being installed in every computer. That would be a local drive installation. Now if the computer doesn't have that amount of stability or that amount of power or amount of space in the computer to install the software, that can also be done by a server based installation software like in Ansys. Ansys can be installed in your server based installations, where you can go and install the software in a mother computer or a mainframe computer, from where the software can be shared or be used by the other co-branched computer. But you need some links with that. That link can be done by small softwares. That's the other thing around. So that in that case, you don't have to install software in each and every computer. You could install in one computer, and that can be controlled by the other computers also. That saves a lot of data and as well in the hard drive. that is forwarded by a cloud-based installation, or it is called IoT, Internet of Things, which most of the computer science engineers study. But they by then we have been successfully done these things, that computer installation is done in the cloud. You don't have to install, also. That is pre-installed over there. You just need to be clicked your ID, password, your email ID or your password, and you could do all the things what you can do with an installed software in the PC. In cloud-based installation, the facility is that you could use it by your mobile phone also. That means that can be before that, let me tell you, there is only one software over here, that is Onshape. Onshape is a design software which can be, which is cloud drive installation. There is another software named Fusion 360. So what you can do is that you don't need to install the Onshape in your computer. You just need to have either Chrome, Microsoft Internet Explorer, or Firefox, any of the browsers, and you could you could design from your home. It is the software is very similar, as well as the same, I should say the similar, it is same to the CATIA or SolidWorks or Solid Edge or AutoCAD. They are this is very similar to it. It's a 3D mapping software. It is used to make mechanical designs only. This is all these are all are 3D, but there are 2D also, but they are majority dedicated to 3D diagrams. And because in mechanical nowadays we use 3D, because we have that flexibility, we don't need to go for 2D, but we need 2D to understand something. But this 2D diagram hardly make any problem. We are basically dedicated to 3D. So this entire Onshape can be done in a mobile, tablets, or computer also. You just need to have an internet connection and a browser. You don't need to install a software, anything, nothing you have to install. Okay, this is called cloud drive installation or cloud based installation or IoT based installation software. Now here comes small things what you need to know about the correction of the things, as well as the how software has a problem, because the softwares are made by multiple companies, and how does it makes a problem while calculation. So we make calculations like there are as you can see that theoretical calculation, basic, scattered and glued, that is called FEM calculation or finite element method, as well as it's there's a practical calculation and simulation calculation, scattered and glued, finite element based. So theoretical calculation is with our books and what we have, as well as the basis with one theory. The name of the theory is finite element method. There are many of them. So after that we could go for practical calculations also with practical models or scaled models. Then we can go for simulations in a computer, make it after before first of all we make the design, then we go for the analysis part. So the simulation is entirely and fully dependent on finite element method. Let me start. This is the basic type. What is the basic type? If a force is applied on a bar, there is a stress. Okay, so what I can write, the stress is equals to force by area, as this is a mathematical derivation, mathematical formulation. So after that, according to Hooke's law, we could find the change in length, that is del is equal to PL by AE or EA. So this is what we do actually. So E is the elastic modulus, L is the length of the bar, P is the load, and A is the area, cross-sectional area. What is the same thing can be done with a scattered or glued, that is finite element method basically. So what we do, it is the simplest form, it is the this is more simplest form, but in a other way around. What we do, we break this body in several parts, and we apply force in each of the part, and After that we add all the force added and all the deformation. So what we do, but to be very simple, note my words, this is the change in length on the of the body. Okay, this is done by our book method. Okay, but in practicality what we do, we use a finite element based. So this is a this is itself a big topic, finite element methods. So we'll not go to the entire depth of it, because it have a you have to go through some very mathematical equations and everything, but I'll make you simple for that in 2 words. Okay, now what is that? Try to understand. If this entire bar is broken into pieces and the force is distributed as shown on the body, after that every piece will have its own deformation. That means if we break this bar in 10 parts or in 4 parts, let me show you, let me get one pointer pen. Okay, if I break this body in 1, 2, 3, that is 4, and more, that is 1, 2, 3, 4, 5, 6, 7, 8 parts, and if I apply a force P, and if I apply a force P over here, so what will happen? This is part 1, part 2, part 3, part 4, 5, 6, 7, and 8. So there are 1, 2, 3, 4, 5, 6, 7, 8 parts. So what will happen? Just try to understand. After applying force on this thumb, that means part 1 will have one elongation, that is del 1. Part 2 will have del 2, so on, del 3, del 4, del 5, del 6, del 7, del 8. So every one will have its own elongation. What we'll do, we'll say that del is equals to del 1 plus del 2 plus del 3 plus so on. So what does it mean? That the change in length is of every parts will be added up to find out the overall display the deformation. Now why is it so? Why we have done it? Because it has been done to understand the problem in micro structure way. So that is why we use finite element methods. That is, you may say, how do I break this in? That means do I need to break it? No, it is done mathematically or with computers. So this is, for your kind information, this is not done practically. We don't have any practical approach for finite element method based. It's only mathematically and your simulation way. So I could show you. Now you can see this is what is this part, 1 part, 2 part. So this is a cantilever beam. Try to understand, this is a cantilever beam. So every cantilever beam will have every elongation. So total elongation can be calculated with the individual elongation of objects. Now this, for example, this part will have one elongation, this part will have another elongation, this part will have another elongation, so on. The total broken parts elongation, if we add all the parts, that means the summation of parts is equals to the total elongation or total deformation of the body. That can be done by finite element analysis or finite element method. So this is very easy, but the thing is that it is complexity. The complexity starts where we go with mathematical approach, like the approach of our for understanding how to develop the formulations or equations because it is where it works, because it's a mathematical approach. We can't break an object in this amount of small. This is only done to understand the micro changes in a body. Okay, this is what we do, this simple thing. Okay. I'll show you in the within the 6th sem there, because you have to study few subjects to understand these things. Okay, next. So let me make you understand what is the problem with these things. In practical this is in the industrial approach. Try to understand, it's an industrial approach. A body is a bar which cross sectional area is 98.61 millimeter square, length is 100 millimeter, for load applied is 10 Newton. So theoretical calculation, that is a simple sigma is equals to force by area, we could find this result. But if I go for UTM approach, I will find out more and less this result I can get it. After, if I go for Ansys, as I have told you, Ansys is a fully dedicated analysis software. In your previous slides, or in the starting of the video I told you. So you could get this result. Again, for this one, if you design it in a SolidWorks, and if you make analysis in Ansys, mark my word, pay attention. If you design in SolidWorks and if you make the analysis in Ansys, you will get this result. If you do the design and analysis both in the Ansys, you will get this result. So try to understand. I am repeating the same. This is the theoretical in our school or colleges. This is the practical, what we do in UTM, that is universal testing machine. That is a practical way approach. This is entirely done by the analysis software we have designed over there. We have made we know that Ansys is a analysis based software, but we could design also. So but the thing is that it's not completely dedicated design software. We note that. But for understanding purpose only, I am doing this one. For understanding purpose, Ansys, we have designed the bar in the Ansys and we are analysis on the Ansys. Again, when we go for SolidWorks, what we can do, we could design. We have designed in the SolidWorks, and we are taking this file to Ansys to analyze it. So you can see the values. The value varies from one point to another. This value, this value, this value. The value differs. That means the stress magnitude differs in the 4 cases, as well as the elongation, as well as the as well as your elongation also. Elongation also differs from 1 to 1, 1 to 1. So what does it mean? This means that this is theoretical, what is simple calculation. This is also practical, what you do, you use the simple calculation only. But here we use finite element, but the software, but the model has been created in SolidWorks. But in Ansys, what you do, the model has been created in the Ansys itself, and it has been analyzed. So what is the outcome of these things? This is what happened. Now see, the value differs from 1 point to 1. This is happening because only this manufacturer problem. What is the manufacturer problem? These two are our theoretical or knowledge problem. We could get it, and practical work. Now SolidWorks is when made by Dassault and Ansys by another company of USA. So Dassault and the companies who manufactured Ansys, they have a conflict. That means the SolidWorks coding, that is the software program, is something else which is not related to Ansys. What does Ansys have to do? Ansys have to convert it. Like what we do, we convert video to audio. That's in same manner Ansys will convert the SolidWorks file to Ansys understandable file. But in this case, Ansys is itself creating the design and it is analyzing. That means it knows the model program, it knows how the program works entirely, it knows that means there will be no problem, there will be no conversation, or there will be no change. Hence, what is the facility of this? The facility of is that this is error, you can find error over here, whereas here in only simple Ansys analysis you will not find any error over here. This is the main reason. So we are in a company, we have to understand, in company we do in this manner only, the industry follows this manner. Each and every design industry like General Electric, Boeing, Airbus, Lockheed Martin, any companies like your PW, Parts and Whitney's, every companies, so every design companies. Okay. So what you can see, as you can see, this is the simulation of Ansys. This is the result of this one. Okay, the result comes in this way manner, and for SolidWorks we get this. Now try to think. This is the thing which we got in Ansys. That means it is showing a pure everything. It's just to understand. And here you can see there is the color changes, so that means it is having a maximum static stress, whereas it is having a least stress. So how could I understand the stress? See the yellow, this is the bar which gives the color code with the magnitude. The yellow is having some color, and this saffron is having another color. So now see, this is saffron, that means the color has been increased. So you could see the stress on over here is maximum compared to this, that is 0.008. This is the maximum, 0.008. So same goes for the deformation, you can see over here. So this is what to do. After that, how to eliminate these conflicts after seeing everything. So we plot graph, simple way, plot graph, theoretical, practical, stress plot graph with the stress amplitude and the stress software as well as Ansys. We see the changes and everything, and we try to find out the best possible method to understand which data is prominent. Okay, there are a lot of work to be gone, like so I'll teach you about the topology management. What is that's not management of computer, MBA, it is a mechanical management topology system of design. So there you will understand how to do. So you could see that there is a change, or the graph dips over here, the graph dips and as well as it increases, the graph dips and it increases, again it falls, but here it doesn't fall. So you have to understand what's going on, what is the main problem with this. So you have to come with a result. So again we can plot in this two graphs in a single plotting, and we could understand how to get the result. So this is what you have to understand. And last but not the least, keep practicing, we'll have everything. The software will hang, software may get corrupted, don't worry about it. Try to make design as possible, design anything which comes in your brain. I'm there to help you out. I'll help you with the industrial drafting and design analysis. I'll be there. This is my WhatsApp number and this is my email ID. You can contact me and I'll help you out with every issues and every problems. Thank you.